So here is this theorem. Let f be a function from a to b, g is another function from b to c, and h is a function from c to d. Then we need to prove that S compose G compose F equal to H compose G first and then compose F. Okay, let's recall the definition of composition. We have two functions f and g. So f from a to b, g from b to c. The composition of the function g with f is a function g dot f go from a to c divided by g dot f of x equal to g of f of x for all x in a. So we have a function f from a to b, the function g from b to c. Then g dot f is a function from a to c. And we see that f send x to f of x, g send f of x to g of f of x. So g dot f from a to c send x to g of f of x. That's a definition of the composition. So now let's prove this one. We need to show that these two functions are equal. So first let's see in this picture we have f and f is a function from a to b, g from b to c, and h from c to d. So we have function g dot f is from a to c, and h dot g dot f is from a to d. So the domain of h dot g dot f is a, the codomain is d. Similarly, we also have the domain of h dot g dot f is a, and the codomain is d. So g dot h dot f, so g dot h dot g dot f. So h dot g, so we do g first and then h. H dot g, composition of g, h and g is from b to d, and then h dot g dot f is from a to d. Okay, now these two functions are equal. Recall we have a theorem, two functions are equal if the values for any x is equal. So let's recall this theorem. We did prove this before. Let f from a to b and g from a to b. Two functions f and g are equal if and only if for all x in a, f of x equal to g of x. So now to prove these two are equal, we just need to prove h dot g dot f of x equal to h dot g first and dot f of x for all x in a. So we call this theorem and we will use it. We need to show that the two are equal. This means that we need to show the two functions are equal at any values at any point x in a. For all x in a, we have this equality, and we just need to compute by definition what is on the left and what is on the right. We have h dot g dot f of x by definition. We call the definition of composition. We had before g dot f of x is g of f of x. So h dot g dot f of x is by definition h of g dot f of x. Okay, and now again we use the definition of composition. g dot f of x is g of f of x. Okay, so we can either continue or we go from the right to these values. If we want to continue, then it's like this. So let's think about this as a valued an element of B, right? F go from A to B, so x map to f of x is in B. So this is a value in B. 8 of g of something in B is 8 dot g of f of x. This is a definition of composition of 8 dot g. So 8 dot g of x is 8 of g of x. And what next? So now we have 8 dot g is a function of f of x. So by definition, composition is a composition of this one with this one. 8 dot g dot f of x. Okay, and this is exactly the right hand side. 8 dot g dot f of x. So these two are equal for all values x in A. And therefore we prove the equality. The two functions must be equal.